Morning, George. Thanks for joining me today on the Just Sit and Ask the Expert. It's very nice of you. Good to see you.
Good to be here. Good to see you again after such a long time.
Thank you very much. Generally, we have some questions that come out of the field, and specifically around slurry sealing. What are some of the key design features that are required in mechanical seal to handle slurry?
Okay. There's a few of them, Michael, but one of the important ones is robustness. When you think about slurry pumps, you think of large cross sections. Well, much the same with mechanical seal. So you need to have robust designs that can cope with abrasion. And for example, like this slurry seal right here, you can see the difference between a slurry seal and a process seal.
Yep.
There's a big difference in the amount of metal that's actually used,
Yeah.
and the ability for the seal to be, for erosion protection to be incorporated into it.
Okay, yeah. So obviously large cross sections, but also stronger metals as well. And
That's right.
And how do they handle abrasives? Is there anything that can be done? They use special materials, or?
Yes, you can use hardened metals, but some of the easiest things to do is to use polyurethanes. Put a coating of polyurethane or a capping of urethane, which is more resilient.
Mm-hmm.
And that resilience allows the particles from the slurry to actually bounce off rather than gouge and impinge, metal
Right.
on their way.
That's clever.
Other things, you could use a epoxy ceramic coating,
Yes.
abrasion resistant,
Yes.
with heavy loadings of ceramics. They work very well. There is a lot more to it to be able to put those on. There's a bit of a skill and the preparation work that goes along with the glands and the sleeves. But that's another way that you can protect the metallic components from abrasion.
From the abrasion, right? That's very good. What about the seal faces themselves, though? We have a special design around that?
Yeah, so there's a couple of things there. You need, firstly, the faces have to be larger cross sections again, because again, you're talking about slurries. You don't want to talk, move and assemble and play around with little fiddly components.
Yes.
So then you've got larger cross section seal faces. There's silicon carbide,
Right.
harder
Some
materials.
hard materials.
So you
yeah.
wouldn't use a carbon or a ceramic in a slurry.
Mhm.
So you go straight away to the hardest materials available for seal faces. There are harder materials for specialty applications like diamond coatings, but that's typically not common.
Yep.
The other thing with the seal faces is you've got a line-on-line design,
Right.
and that allows for the wear to actually take place more evenly
Okay.
and for the seals to actually last longer.
Okay, because that's really important, because you have to make sure the lubrication between the
Yep.
two faces is happening. So in a slurry application, it's very difficult for lubrication to actually get through the seal faces. So what are some of the things we should do or consider in that respect to help the lubrication side?
So with the type of slurry, it's going to be important for the lubrication, because the finer the slurry, the more it's actually going to hold the water within the slurry itself. And that's not going to be good for lubrication. For lubrication, you need free water.
Yeah.
So for example, pulp and paper. There's a slurry of pulp and water, paper stock. That tends to hold the water quite a lot. So there's very little lubricant left for the seal faces. The coarser solids, like sands, they're great because then you've got plenty of free water. Say, for example, you shook a glass with sand and water in it, you can watch it settle quite quickly.
Yep.
Very different to if you actually had very fine clay and you shook that, it would take a long time to settle.
Yes.
So the longer it takes the longer time it takes to settle, the harder it is to actually lubricate that with that fluid for the seal faces. And of course, that's for single mechanical seals.
So is it something we can do to improve that? Like, can we put a flush in there, for instance?
Yeah. So a flush will work to actually reduce the amount of solids that are around the seal faces. So in essence, you're creating an artificial environment around the seal. And by doing that, you can actually lubricate with cleaner fluid. The other option would be to go to a double seal. Then of course you've got the expense and of the system, the double seal itself, and the maintenance of that system as well.
Yeah, that would make it more expensive, I suppose.
Yeah.
Yeah.
But sometimes that's what you need to do to be able to get success.
Okay. All right, so we're looking at some robust materials, something that we can protect against the abrasives, inline faces, hard material faces, etc.
That's
If we can
right.
get a flush that would be great. That's another option. So I guess, so they would be the key requirements for a seal design.
Anyone looking at mechanical seals should talk to the experts, ask the questions about
The applications.
The application itself, the pressures, temperatures, all that kind of stuff that's important for seal selection.
Thanks, George. We'll see you in the next Ask the Expert.
Cheers, Michael.